process, like from beginning to end, to creating SQL that creates tables and the whole pipeline point that we
Yeah, so probably not. So let me okay, so in this public repository, do you guys have access to this DDW public?
looks like I do, yeah.
Yep. So you're there. Right access. And Car, when you're an admin, so you can do whatever you need to do. So so now let's go. So there's two things, right? So one, whenever you change SQL, you'll come in, you'll create a branch, you make whatever changes, you do a pull request. The pull request gets assigned to an approver. It's me and Malenga. I'm the only one that ever seems to do them. And then I publish them to production manually. Would love it if we automated it, but for now it is what it is. So out in Confluence, there are instructions on how we do this process of, making changes, testing it, deploying it, and you're golden. I'll put this in chat. And then, so right here is all the objects, right? And this is, so these are the steps in the order they run. I believe we can retire some of these steps because we ended up changing, but I never retired them. But when I did my test with Databricks, that gave me it was like 11 steps that actually had dependencies, right? I not Databricks, when we used DBT, right, that pilot. So I've become a big fan of DBT. Anyways, we're not. So So I'm just going to walk through and talk to these, right? So the first one is the calendar, and this is just taking the calendar that exists in SAP and building it for our use. We use it to determine the number of working days per month, right? So and all these tables exist in stage data products, and then if you ever change the fields or the field names, right, a breaking change, then you would have to change the underlying views that exist in the data products. So project systems holds the hierarchy views. Human resources is the timesheet data, and accounting is the manpower data. And so as you go through these steps, right, it'll build out the data sets that the views in the data product point to. So typically it's changing the logic or the calculation of a field, but not changing the structure of the underlying table. So we don't have to rebuild the view. So anyways, so one is the calendar, right? It's very simple, and it builds it out. In SAP, right, the months we're in calendars, all this does is unpivot it. So our calendars, it just gives us a nice row, right? So it gives us the year, the month, and the number of working days in that month. Number two, this never gets run. This was run once. This creates the unit table, and this was the manual upload of data that Robert Stetson gave us. Eventually, so there's a spreadsheet application called the PET tool. There's supposed to be this EVMS tool, web EVMS or something like that will eventually replace Dacian and the PET tool. And at that point, right, we should be able to pull this units data from there. Now, my understanding, I think the PET tool is an Excel front end. I think there's an Oracle database behind it. So if that web EVMS doesn't come along, we could always look at can we get the units from that Oracle database if the PET tool is going to reside. Units don't change that frequently. I think like once a year you have to go look, do we need updates? So this is a guy that's just, right, it is a snapshot. So if anybody ever says, hey, I'm missing a unit, it's this raw data because we don't have a good link for it. And then projects is built off of SAP data, and this is where we start building out, right? So, right, projects have their own. So the project that people see is actually the WBS element for the project. That's the ME dot. The actual project in SAP is missing the dot, so we formatted the project. The WBS in SAP, it's right. It has its own internal structure. So all we did was create the visual formatted field that people are used to seeing. And when we run this, we do have filters, right? So there's like 800,000 projects that exist that have WPS structures, right? Every engine, every module has its own type of project. The projects we care about are this YPS type. and that's the CE.
that
That filters us to like 11,000 CE and ME projects. And then LOEDM is the deletion indicator. So in SAP, they have soft deletes. So we're just saying, hey, if SAP deleted the project or WBS, don't pull it in. And then network activities. Again, this is just getting all the networks and activities with their cost elements pulled up. We do create indexes on some of these structures, and then we update stats. So you would run the whole thing and it'll look to see, hey, if it exists, drop it, recreate it, whatever. All of these run pretty quick. Again, deletion indicator. And when we build the lower structures, we're always filtering on only pull those structures associated with the projects or WBS that we built in the previous steps, right? Work centers, I believe this is one of the ones that is no longer required. I'd still run it to go validate it. I actually think I have a PowerPoint that has DBT with DBT pulled out as, hey, here's all the dependencies based on some changes we did. Because when you look at this, we have these work centers, and then we have work cost center, cost element we don't use anymore, profit center groups. So it ended up being this work center hierarchy that we use, profit center hierarchy, which is actually still touching the profit center groups. So we can ignore it. So I just run them all in the steps, So if you're testing, just run the steps. I wouldn't until, anyways. So this step, orders, again, it's just like these other steps. It builds the hierarchy of orders. We don't actually use orders in Manpower, right? Orders, if you ever get to a point where you're looking for material charges, they can get assigned to orders. I didn't realize that when I first created it. I thought, it's a cost collector, so I included it, but apparently Manpower never gets associated to orders.
We are going to be using that next, I think.
Okay. And then Manpower. So this is the base Manpower data that we started with, and it's essentially it goes out and it gets primary costs, and then it goes out and gets secondary costs, and then it gets primary hours and it gets secondary hours. So it's this big union of 4 different data sets.
What does primary and secondary mean?
So there's so I don't know, right? So there's 2 tables, COSS and COSP. COSP is primary costs and COSS is secondary costs. Both of them have to be aggregated to get the total costs. I don't remember the difference between primary and secondary costs. Robert probably could tell you. I don't know if it has to do with cost elements or what, but both are required. And then it's a really wide. Both of them are really wide tables. The hours are stored. So each row in those tables is based on a year, and then the months are stored in columns, and they're stored in different columns depending on whether they're hours or dollars. So we do this pivot just to pivot so that we have one row is costs per month, right? And that's how we pull it, so it's a little more natural to work with. So that was created a while ago. but then there became the discussions around adding hierarchy to the manpower data, and I kept screwing up the number of rows, right? So one of the right, you always got to build it such that when you do your joins, you shouldn't be getting additional records, and it just became complicated. So I just kept the hierarchies as themselves, right? So the groups are just getting textual names associated with the groups. This employee lookup is like creates a big table of the current employees. I don't know if you remember, we had the current employees, but we had to look up the employee and their supervisor from based on the date of when it was charged. So I actually, there's views that we use to do the lookups, right? So these are pretty clean, and I don't believe we use this this table anymore because we didn't want the current, but it still exists there. And really, what we do care about is the profit center hierarchy and the work center hierarchy are the two hierarchies that they care about, they filter on, and that's how they want to aggregate the data. And then once we get through all those steps, those hierarchies are associated with both the timesheet data structure, and this is where I take the manpower that was created up here and I associate it with the hierarchy. And that seems to work pretty good. Right, so this is just taking that manpower data set and connecting it with some of the key additional data sets that give them their full. And then the view manpower points to this manpower underscore hierarchy table. So
when you've got things like, when you're creating the table, you've got like this distribution hash, is that a performance optimization?
Yeah, so let's talk about that. So with Synapse, today we run 3,000 data warehouse units. So that translates to 6 nodes, and every table within Synapse has 60 distributions. So it tries to distribute the data across those 60 distributions. So you have 10 distributions per node. So whenever you run a query, it pushes it out to the nodes.
Mm.
So the distribution, so typically when people come in, they're looking for a project, and an individual project doesn't have a lot of data, and everything's in this one. So right now I have it hashed on project. So that is essentially going to make one node do the work when it's a request for one project.
Mm.
So you may look at it and say, yeah, I don't know that that's the best answer, but oftentimes it's, so that's something to think about. Do you want it by project? And then we have a clustered index on NA object. This is the object number of the network activity. And now that I'm thinking about it, I'm not crazy about this structure, right? So when we get costs, we do use the NA object, but that's usually the things that we access as we build up this data set. When this data set's queried, it's going to be queried on project and return all the records. For Click, it just pulls the whole table. But this becomes critical in how you want to distribute the data. I believe. So we might want to think about. So there's like 11,000 projects. So each individual project isn't going to have a ton of records. So these are pretty quick. We may want to look at size. So we ran a script on Saturday, and every table. So almost all of our tables used round robin instead of a hash, and that allows you to have good distribution. But it's terrible when you do a query with joins because it's gonna end up having to cross the network to find the data elements that it's joining with. So this Saturday we took everything that had every table that was 2 gigabytes or smaller. We changed the distribution to replication, and replication puts your data on every node. So there's no network. So it pins it. So I'm not sure how big these tables are. Manpower has 28 million rows. So I don't know how big, if that ends up being 28 megabytes or 280 megabytes, right? We may want to just pin these, right, for speed, but the reality right now is that Click grabs these data and just,
But I am actually hitting manpower directly from Team Express.
Is it causing you pain, or is it pretty good?
It takes a few seconds, but it's not horrible. But there's definitely a few seconds delay.
So when it takes a few seconds, is that from the API in AWS, or is that from just connecting directly to the database?
Yeah, I don't know. I haven't influenced it to that level yet.
Yeah, because so there's probably like a second and a half latency. Well, so it depends on how much data you grab, but I want to say it feels noticeable, but you know what? Let's do this. Let's go. Maybe I closed it already. So if we go